Welcome back all of you to Appleby Academy classes. Today we will be dealing with the portion Matrices. We will be looking in detail the previous year questions from 2020 to 2023 which has been asked from this area. So let's see in detail each question. First we will look at the question which was asked in June 2021. So the question goes like this. Which of the following are the correct features of matrices? And 4 options are given. We will see in detail each option. So the first option is an identity matrix is a square matrix. Okay. An identity matrix which is represented by I is a square matrix. Okay. So what is an identity matrix? So an identity matrix is a matrix of order n into n where the diagonal consists of ones and the other elements are all zeros. Okay. So the diagonal elements are 1 and the other elements are 0. Okay. So this is how this is a 2 into 2 identity matrix. This is a 3 into 3 identity matrix. Okay. So what is an identity matrix? An identity matrix is a matrix of the order n into n where the diagonal elements are 1 and the rest of the elements are 0. Okay. So obviously an identity matrix is a square matrix. See, this is of order 2 into 2, this is of order 3 into 3. So the first statement, an identity matrix is a square matrix, is true. Now the second statement, an identity matrix when get transposed remains an identity matrix. Okay. So an identity matrix when gets transposed remains an identity matrix. Let's see that. 1 0 0 1. Okay. Taking transpose. What do you mean by taking transpose? Transpose means interchanging the rows and columns. Taking the transpose of a matrix means interchanging the rows and columns. So when you interchange the rows and columns of this matrix, you can see here the first row is 1 0. That becomes the first column 1 0. Second row is 0 1. That becomes the second column. So 0 1. Okay. So taking the transpose of identity matrix, you get again the same identity matrix. Okay. See, we will look this one also. Let's take the transpose of this one. So that is 1 0 0 0 1 0 0 0 1. Okay. First row has been changed to first column, second row, second column, third row to third column. So again it's an identity matrix. So the second statement, an identity matrix when gets transposed remains an identity matrix. That is also true. Now the third statement is AB whole transpose is equal to A transpose into B transpose. Okay. So the third statement is A into B the whole transpose is equal to A transpose into B transpose. Okay. So here this means that you are multiplying matrix A and matrix B and then taking transpose, that would be equal to A transpose into B transpose. No, this statement is wrong. So the correct statement is when you multiply two matrices and take transpose, this would be equal to B transpose into A transpose. This is the correct statement. A into B the whole transpose is equal to B transpose into A transpose. You can check this with any two matrices. You can multiply A and B and then take transpose and then take B transpose into A transpose. So, this will be proved if you can take any two matrices and do this operation. Okay. So, transpose is basically interchanging the rows and columns. So, this third statement is wrong. Now, the fourth statement is A inverse the whole transpose. A inverse the whole transpose is equal to A transpose the whole inverse. Okay. A inverse the whole transpose is equal to A transpose the whole inverse. Okay. How do you find the inverse of a matrix? Inverse of a matrix, A inverse is equal to 1 by determinant of A into adjoint of A. This is how we find the inverse of a matrix. A inverse is equal to 1 by determinant of A into adjoint of A. So, this statement is correct. First, if you find the inverse and then take transpose, that would be same as first finding the transpose and then taking the inverse of it. So, statement D is also correct. Okay. So, the question is, which of the following are the correct features of matrices? So, option A, B and D, that is an identity matrix is a square matrix, that is true. An identity matrix when gets transposed remains as an identity matrix, that is also true. Then the next statement, A into B transpose is equal to A into B transpose is equal to B transpose into A transpose. So, third statement is wrong, and the fourth one, A inverse the whole transpose is equal to A transpose the whole inverse. So, this fourth statement is also correct. So, A, B and D are true. Next, we will move on to the second question. So, the question, this question was asked in June 2021. So, identify which one of the following statements is correct. So, the first statement is A inverse is equal to adjoint of A if the value of the determinant A is unity. Okay. So, the first statement, A inverse is equal to adjoint of A. So, the formula for A inverse is 1 by determinant of A into adjoint of A. So, this statement says A inverse is equal to adjoint of A if the value of the determinant A is unity. Okay. So, if the value of the determinant is equal to unity, then A inverse equal to adjoint of A. That statement is correct. See, if this denominator portion is equal to 1, then A inverse will be equal to adjoint of A. So, the first statement is correct. Second one, if two columns of a determinant of a matrix are interchanged, then the sign of the determinant does not alter. Okay. So, 1, 2, 3, 4. The statement is if two columns of a matrix are interchanged, then the sign of the determinant does not alter. It says that when two columns are interchanged, the sign does not alter. We will see. So, how do you find the determinant of this matrix? Principal diagonal elements minus the other diagonal elements. 1 into 4, 4 minus 3 into 2, 6. So, this is minus 2. Now, we will interchange the columns. Okay. So, we have 2, 4 and 1, 3. Okay. 2, 4 and 1, 3. So, this is 3 into 2, 6 minus 4. So, determinant is 6 minus 4, which is positive 2. So, from this it's clear that when you interchange the columns, what happens? The sign of the determinant changes. Okay, when you interchange any two rows or columns, the sign of the determinant will alter. So the second statement says that the sign of the determinant does not alter. So that is wrong. Now, the third statement is law of division is allowed in matrix operations. No. Actually, we have subtraction, addition and multiplication in matrices, but law of division is not allowed in matrix operations. We cannot divide two matrices. Okay. Now, the fourth one, the value of the determinant changes if the rows and columns are interchanged. The value of the determinant, okay, the value of the determinant changes, okay. So, the value does not change. What changes is the sign of the determinant, okay. So, the value of the determinant does not change when any two rows or columns are interchanged, but the sign of the determinant changes. Clear? So, the first statement, which is A inverse is equal to adjoint of A if the value of the determinant A is unity, that is correct, since if determinant is equal to 1, then A inverse will be equal to adjoint of A. Second statement, if two columns of a determinant are interchanged, the sign of the determinant does not alter, that is false. If two columns or rows of the matrix are interchanged, then the sign of the determinant changes. Third one, law of division is allowed in matrix operations, that is also false because law of division is not allowed in matrix operations. Then the fourth one, the value of a determinant changes if the rows and columns are interchanged. Value does not change, but the sign changes. Okay, so which of the following statements are correct? Answer is A. Only the first statement is correct. Okay. let's look at the third question. This question was asked in June 2022. So the question is, find the rank of this matrix. This is a 3 into 3 matrix. So the 3 into 3 matrix, the question is, find the rank of A, which is equal to 6, 3, 5 minus 10, 2, 8, 5, 2, 3. Okay. Usually we know to find the rank of a matrix, it is a very long procedure, but we have a shortcut to find the rank of a matrix, and it is very easy also. Okay, first what you need to do is, you need to find the determinant of this matrix A. Okay, so you need to find the determinant of this matrix A. If the determinant is a non-zero number, then the rank is equal to 3. Since this is a 3 into 3 matrix, see, this is a 3 into 3 matrix, or you can call it as a n into n matrix. If the determinant is a non-zero number, then the rank will be equal to n. Okay, here in this case, the rank will be equal to 3. The determinant is a non-zero number. But if the determinant is 0, then what you need to do is, you need to take the sub-matrices of this particular matrix. Okay, so you can take different two combinations of 2 into 2 matrices from this matrix. For example, 6, 3 minus 10, 2, that is a 2 into 2 matrix. 3, 5, 2, 8, that is a 2 into 2 matrix. So you can take 1, 2, 3, 4. 4 2 into 2 matrices from this particular matrix. You need to find the determinant of all those matrices. If you get a non-zero number for any of those determinant, then the rank will be equal to n minus 1, here is equal to 2. Or if you are getting the determinant as 0 for every matrix, every 2 into 2 matrix plus this entire matrix, then the rank will be equal to 1. Clear? So we will do this, then you will understand this in detail. Okay. So first what you need to do, you need to find the determinant of this matrix. Let's see whether the determinant is 0 or not. Okay. So determinant of A is equal to, okay, I am expanding this or I am solving the determinant using this particular row. Okay, so 6 into 3 into 2, 6 minus, when you take the first element 6, you need to delete the elements of this particular row and column, and then you need to consider this matrix. So 3 into 2, 6 minus 8 into 2, 16 minus 3 into minus 30 minus 40 plus 5 into, deleting this row and column, you get minus 20 minus 10. Okay, so you get 6 into minus 10 minus 3 into minus 70 plus 5 into minus 30. Okay, so you get minus 60 minus plus 210 minus 150. Okay, so 150 plus 60 gives you minus 210. So this is equal to 0. So you get the determinant of this particular matrix as 0. So now next what do you need to do? So one thing is sure, now the rank of the matrix is anyway not 3. So the option A can be eliminated now. The rank will not be 3. Now we need to check whether the rank is 2 or 1. Clear? So now you need to check the determinant of 2 into 2 matrix. Okay. So First we will take this matrix, that is 6, 3, minus 10, 2. Okay, 6, 3, minus 10, 2. So that is 12 plus 30. Okay, so 12 plus 30 you get 42. Okay, now you need not check further, because if you get the determinant of any of the 2 into 2 matrix in this particular matrix as a non-zero number, then the rank will be equal to 2. If you get the determinant of all the matrices, all the 2 into 2 matrices inside this one, then the rank will be 1. So solving 6, 3, minus 10, 2, we got it as 42, that is a non-zero number, so the rank will be equal to 2. I will just mention the other matrices, other sub-matrices in this particular matrix. The other ones are 3, 5, 2, 8, comma, minus 10, 2, 5, 2, and the next one is 2, 8, 2, 3, 2, 8, 2, 3, okay. In case if you were getting the determinant of this particular 2 into 2 matrix as 0, then you need to check the determinant of this one. Then again if you are getting 0 for this one, then you need to check this one, and lastly this one. Okay, if you are getting the determinant as 0 for all the sub matrices, then the value of the rank will be 1. Okay. If you are getting a non-zero number for any of the 2 into 2 submatrix, then the rank will be 2. So for this one, the rank is equal to 2 because the determinant of A is equal to 0, but when you look at the submatrices, you are getting a non-zero determinant. So the rank will be equal to 2. Hope this is clear to you. Now we have seen 3 questions. The next question has been asked in June 2020 NET exam. So the question goes like this: which of the following properties of matrix are correct? Okay, and we have a few options given. The first one is A transpose, the whole transpose is equal to A. Okay, the first one is A transpose, the whole transpose is equal to A. We will check that. We have 1, 2, 3, 4. Transpose means what? Interchanging rows and columns. Taking the transpose of this one, we have 1, 2 and 3, 4. Again taking the transpose of this one, we have 1, 3 and 2, 4. Okay. So this is the original one. Taking 2 times the transpose, you get the original matrix. Okay, so the first option is correct. A transpose, the whole transpose is equal to A. Second one, the rank of n into n singular matrix A must be less than n. Okay, so first you need to know what is a singular and non-singular matrix. Okay, when you say a particular matrix is a singular matrix, that means the determinant is equal to 0. Singular means determinant is equal to 0, and non-singular means determinant is not equal to 0. Clear? So, the rank of an n into n non-singular matrix. Non-singular matrix means determinant is not equal to 0. Non-singular matrix A must be less than n. Okay, so if it is a n into n matrix, okay, so what is the rule for the rank? Okay, so if you have a 3 into 3 matrix and when you are finding the determinant of that particular matrix, then if you are getting a non-zero number, then the rank will be equal to n. But if the determinant is equal to 0, then the rank will be less than n. So, if it's a singular matrix or if the determinant is equal to 0, then the rank will be less than n. Here the statement just the opposite is given. The rank of a n into n non-singular matrix A must be less than n. Actually, that sentence should be the rank of a n into n singular matrix A must be less than n. Okay. If it's a singular matrix, then the rank will be less than n. But if it's a non-singular matrix, then the rank will be equal to n. Clear? Okay. So, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 3 into 3 matrix. If the determinant of A is equal to 0, okay, then the rank will be less than n. Okay. If the determinant A is not equal to 0, then the rank will be equal to n. Hope that is clear. Okay. The determinant A is equal to 0, rank will be less than n. The determinant A not equal to 0, then the rank will be equal to n. Then the third statement, AB whole transpose is equal to A transpose into B transpose. So that is wrong. We know that AB whole transpose is equal to B transpose into A transpose. Okay, this is a statement. AB whole transpose is equal to B transpose into A transpose. Next one, option D. A plus B into n is equal to A into n plus B into n. Okay. A plus B into n is equal to A into n plus B into n. We will see that. Okay, so A and B are true matrices. N, you are multiplying A and B with a number n. Okay. So, you have the option D. We have A is equal to 1, 2, 3, 4. B is equal to 5, 6, 7, 8. Okay. So, first statement is A plus B into n. So, we need to add these two matrices, that is 5 plus 1, 6 plus 2, 7, 8, 10. Okay. And into 2. Let's say n, you can consider it as 2. So, you get 12, 16, 20, 24. Okay. 12, 16, 20, 24. Now, the next statement is A, it is equal to A into n plus B into n. A into n plus B into n. Let's see. A into n is A into n is 2, 4, 6, 8 plus 10, 12, 14, 16. Okay. So, now adding it, you get 12, 16, 20, and 24. Okay. So, LHS is equal to arches. So that statement is also correct. A plus B into n is equal to A into n plus B into n. Okay. Now the next option is A transpose the whole inverse is equal to A inverse. Okay. The last option is A transpose the whole inverse is equal to A inverse. No, that is not correct. Okay. A transpose the whole inverse is equal to actually A inverse the whole transpose. If this was a statement, then it would have been correct. But here it's given A transpose the whole inverse is equal to A inverse. No, that is not correct. If A transpose the whole inverse is equal to A inverse the whole transpose, then that statement would have been correct. Okay. So, I'll just explain it once more. Which of the following properties of matrix are correct? First one, A transpose the whole transpose is equal to A. We have seen that transposes interchanging rows and columns. You have a matrix A, you take the transpose of it, again you are taking the transpose, you get the original matrix A. So that is correct. Second statement, the rank of a n into n non-singular matrix A must be less than n. No, that statement is wrong. Instead, it should be the rank of a n into n singular matrix A must be less than n. Singular matrix means determinant is equal to 0. That is the case, then it must be less than n. Rank will be less than n. Next statement, AB the whole transpose is equal to A transpose into B transpose. No. AB the whole transpose is equal to B transpose into A transpose. Okay. Now the third statement, A plus B into n is equal to A into n plus B into n. We have seen that. That is a correct statement. And the last option is A transpose the whole inverse is equal to A inverse. No. A transpose the whole inverse is equal to A inverse the whole transpose. If this was a statement, it would have been correct. So the correct options are option A and option D. Option A and option D are true. Okay. So with this, we have taken, we have covered every questions from previous year part, that is from 2020 to 2023. Hope you have understood this portion clearly. Thank you.